Hey everybody, and welcome to Cabling for Wireless Networks. Our whole goal here is to become familiar with the standards and the processes for installing the wireless systems themselves. Now, wireless networks are becoming increasingly more important because of their unique properties. Wireless computer networks allow users to connect to the network without they're using their wireless cards in their PCs, making them popular with mobile users such as workers in hospitals, warehouses, or traveling salespersons. Travelers can have network access in airports, hotels, and even restaurants and coffee shops. The structures where installing cabling is difficult or disruptive and can often benefit from the use of some of these wireless networks. Wireless network standards are still evolving, and most wireless computer networks use an RF transmission radio frequency and are based on the IEEE 802.11, which are still under constraint and or under constant development and updating to improve service and speed. An alternative to radio frequency would be Bluetooth. It's used for short distance connections, like 30 feet, mostly for consumer devices like your headphones and your phone and connecting your phone to your car, stuff like that. Several wireless networks have been developed using infrared, but none have become widely used because they're limited range and they have to be line of sight. And the biggest concern about wireless, however, is security. Now, unless carefully set up, the security of wireless computer networks is minimal. Practically anyone with a laptop and a wireless card can access any RF wireless network, creating security problems. Now, anyone considering a wireless network, whether it be commercial or residential, should thoroughly understand and carefully set up security to limit any unauthorized use. One should not be concerned that wireless will be making cabling obsolete. Wireless is limited to connection speed, harder to manage, subject to interference from other RF devices such as remote controls. It is more expensive than cabling. And one thing we all need to understand and remember, wireless is not wireless. Okay? What do we mean by that? Well, the easiest way to understand wireless is to think of it as a link that replaces the patch cord that connects a PC to the network. A wireless network diagram looks like zone cabling, and the final drop to the desktop replaced with a wireless link. The wireless antenna, officially called an access point, but also referred to as a hotspot, is a lot more than that. It's a radio transceiver and a network adapter matching the PCMCIA card that you insert into your laptop to access the network with some logic that implements part of the network protocols, allowing access to the network and sharing among several users. The transceiver in the AP, or access point, has limited power, so that the distance from the antenna to your laptop is limited. The connection between the PCs and the access points can be affected by metals in the building, which reflect or attenuate the signal. For those of you who don't remember, attenuation is a weakening of a signal over time and distance. Now, a typical office building may need 4 to 12 access points per floor just to get consistent connections throughout the area. It means you're going to end up with, 12, 4 to 12 cables being run on that floor. The AP is connected to a wired network, just like a PC, using unshielded twisted pair or fiber optic cable to a local hub, which connects it into the network backbone. Not only does the wireless access point require a network cable to connect to the network, but it also needs power, uninterruptible power, just like any network hub or switch to operate. In some systems, the power is provided over the 2 spare pairs of unshielded twisted pair cable using the Power over Ethernet standard, 802.AF. So replacing a wired network with a wireless one does not mean you don't need cabling. You may, in fact, need more than you consider may need more when you consider the power needs of the access points. Any advantage of wireless network is not the installation, but in the flexibility of the user being able to roam and maintain their connection. So how do they work? Well, wireless LANs use electromagnetic waves or radio, which are radio or infrared, to communicate information from one point to another without relying on any physical connection. The data being transmitted is superimposed on the radio carrier frequency so that it can be accurately extracted at the receiving end. It's generally referred to as modulation of the carrier by the information being transmitted. In a typical wireless LAN configuration, the transmitter/receiver device called an access point connects to the wired network from a fixed location using standard Ethernet cable. At a minimum, the access point receives, buffers, and transmits data between the wireless LAN and the wired network infrastructure. A single access point can support a small group of users and can function within a range of up to several hundred feet. The access point, or the antenna attached to the access point, is usually mounted high, but it may be mounted essentially anywhere that is practical as long as the desired radio coverage is obtained. End users access the wireless LAN through adapters, which are PC cards in notebook computers, ISA or PCI cards in desktop computers, or fully integrated devices within handheld computers, like your phone or a tablet. The adapters provide an interface between the network operating system and the airwaves via an antenna. The simplest wireless LAN configuration is an independent or peer-to-peer network that connects to a set of PCs with wireless adapters. Anytime two or more wireless adapters are within range of each other, they can set up an independent network. These on-demand networks typically require little administration or pre-configuration other than configuring security. Access points can extend the range of independent LANs by acting as repeaters, effectively doubling the distance between wireless PCs. What you're looking at here is your typical wireless LAN configuration, which takes us to a little thing called microcells. Wireless communication is limited by how far a system's signals can reach. Wireless LANs use microcells, or small cells, to extend their system's range. This is similar, as the name would indicate, to cellular phone technology. At any point in time, a mobile PC equipped with a wireless LAN adapter is associated with a single access point and its microcell, or area of coverage. Individual microcells overlap to allow continuous communication within a wired network. They handle low power signals and hand off users as they roam through a given geographic area. The distance over which radio signals can be used to communicate is a function of product design, including transmitted power and receiver design, and the propagation paths, especially in indoor environments. Interactions with the typical building objects like walls, metal, or even people can affect how the magnetic energy propagates, and thus the range and coverage that a system achieves. The range, or radius of coverage for typical wireless LAN systems, varies, but can be extended by using microcells. Any indoor wireless network will require thorough site surveys to ensure proper coverage. A wireless LAN includes an infrastructure. A wireless LAN includes infrastructure costs for the wireless access points and user costs for the wireless LAN adapters. Infrastructure costs depend primarily on the number of access points that are deployed, and the access points range in price from a few $100s and on up. The number of access points required depends on the required coverage region and the number and type of users to be serviced. The coverage area is proportional to the square of the product's range, and wireless LAN adapters are required for standard computer platforms and are generally less expensive than access points. Now, all of these are then susceptible to what we call interference. And the unlicensed nature of radio-based wireless LANs means that other products that transmit energy in the same frequency spectrum can potentially cause interference within a wireless LAN system. Even microwave ovens, garage door openers, or other remote controls are potential concerns, but most wireless LAN infrastructures design their products to account for these interferences. Another concern is the co-location of multiple systems. Now, although co-located systems from different vendors may interfere with each other, others coexist without interference. Now, this issue is best addressed directly with the appropriate vendors, which takes us into the wireless LAN standards. Now, numerous wireless LANs have been introduced, but only two currently have significant usage. The 802.11, which is Wi-Fi, and of course, Bluetooth. Bluetooth is a limited distance network primarily intended for use with consumer products like cell phone headsets, and is not common in commercial applications. Now, there are four current 802.11 versions operating at two frequencies in unlicensed bands. The 802.11g is the most widely used, although 802.11n may become more prevalent in the future, or even now, as an upgrade to 802.11g. The 802.11a offers high data rates, but its higher operating frequency makes it more limited in operating range, and its usage has declined. The versions of the 802.11 wireless networks are continuously under development, and standards are evolving, somewhat limiting interoperability among available products. Now, most users choose products of known interoperability to ensure proper system applications. Now, another one that we need to talk about is WiMAX. Now, WiMAX is a long range, and we're talking several kilometers as opposed to several hundred feet. Okay? A long range wireless network designed for connecting Wi-Fi hotspots and subscribers as an alternative to DSL or other broadband connections. Now, standards are developed under the IEEE 802.16, which obviously is different than the wireless 802.11, which is Wi-Fi. The 802.11.16 committees, and these represent diverse technologies adapted for various applications. Now, since WiMAX is not generally considered a premises application, we're not going to be discussing it in any detail in this because this is more of a cabling book that we're going over, and since we're not cabling satellites, we're going to just like basically breeze over this topic. Now, Wi-Fi access points will use standard network cabling. Example, the unshielded twisted pair, Cat5, Cat5e, Cat5, Cat6, Cat6a, and also fiber optics for their connections into the network. However, one should always review specifications for any network devices to ensure the cabling chosen is compatible. Now, any LAN application or network operating system or protocol will run on 802.11 compliant wireless LAN as easily as it'll run over an Ethernet network. It'll just be slower. Now, to establish a wireless LAN, you must install and configure the access points and the NICs. In addition, you'll probably need to install cable from the existing network infrastructure to the access point because they are rarely located near existing outlets. Generally, access points are located in or near the ceiling to extend the range and reduce interference from room furnishings. The number of access points depends on the coverage area and the number of users and the types of services that are required. The single most important part of the installation is placement of the access point to ensure proper coverage. Most manufacturers provide a site survey tool to measure local signal output. Place the access points and use the site survey tool to record signal strength and quality while roving within the intended area coverage. Once the access points are installed, access points and NICs must be configured. Configuration options vary based on the manufacturer. So when you're designing a wireless LAN, the cost of the equipment is just one concern. You must also consider installation and maintenance expenses. Now, although 802.11a, b, or g compliant products are based on a standard, the standard offers no guarantee that that access points, NICs, and other equipment from various manufacturers will interoperate together. But be sure to choose equipment from compatible vendors or talk to equipment suppliers to ensure that you will have no problems. In a few years, everything will probably be seamlessly interoperable, but for the moment, the responsibility lies with the network designer. Now, because the acceptance of any network depends on multi-vendor interoperability, industry leaders have formed a group called the Wireless Ethernet Compatibility Alliance, or WICA, to certify cross-vendor interoperability and compatibility of 802.11b wireless networking products. Now, this group has created tests to certify interoperability and announced the Wi-Fi standard, which is an awarded seal for those wireless LAN products that have successfully completed the prescribed interoperability testing. It provides the assurance that products bearing the logo will work together. Now, the Wi-Fi effort is effective to the extent it reaches, but understand its limitations. its limitations. So, for example, both 802.11 and Bluetooth share a common spectrum, in the fact that they're both 2.4 gigahertz. 802.11 devices can provide a mobile extension to wired networks in large enterprise installations, and even replace a cabling infrastructure in small office and home office environments. Meanwhile, Bluetooth is available to the mobile worker and business traveler. It is useful for sending email to a laptop using a cellular telephone, synchronizing palm-top devices, and accessing local printers. It is inevitable that 802.11b and Bluetooth will bump into each other at some point. Currently, studies are underway to see exactly what the effects will be, but it's known that 802.11b's susceptibility to Bluetooth interference increases as the distance between wireless nodes and access points increases, due to the fact of attenuation. Now, before a wireless network can be installed, the installer or designer must first do a thorough site survey. Essentially, setting up a wireless network is the same as setting up a cellular telephone system, except on a much smaller scale. So if you do not do a thorough site survey, the network may end up with what we call dead zones or dead spots, where no signal can be transmitted. Elevator shafts, kitchens, cabinets, metal cabinets, thick concrete walls, steel studs, and even large metal fans can seriously restrict the effectiveness of a wireless installation. A good site survey addresses two primary concerns. First, it examines the signal coverage requirements for the site. And secondly, the site survey enables you to understand the overall networking and system requirements. Does the existing backbone have adequate bandwidth to handle the overlaid wireless network? Are there sufficient resources to support the wireless capabilities needed? So in performing the site survey, use the tools and equipment provided by the wireless equipment vendor. And if you're installing, designing, or selling a wireless LAN for the first time, it'd be advisable to have a specialist come in and walk you through the process. The 6 major areas that you want to consider when you're designing your site would be future use, coverage areas, capacity, interference, power requirements, and the cost and ease of the installation. Setting up temporary antennas and access points. The most important task when installing a wireless network is to do a physical site survey. This process includes assessing every part of the site with temporary access points and a software survey tool installed on a handheld computer or a laptop that monitors the signal and identifies failure zones. Site surveys differ in their complexity and level of effort based on technology and space. Small facilities may not require one at all, and you can often use only product specifications and a good set of blueprints. However, in larger installations, a site survey offers a level of security in an area in which, unlike wired networks, there are many variables to consider with a few fixed rules. A thoughtful, accurate, and effective assessment of coverage and system requirements will make the wireless LAN installation more straightforward and less expensive while laying the groundwork for an ongoing expansion. In summary, most existing wireless standards are versions of the 802.11. Others are in development for specific uses, but the 802.11 is by far the most widely used, and wireless networks are wired to cabled networks. Almost none are entirely wireless. Signal quality for wireless networks can be adversely affected by electromagnetic interference. Proper planning, site survey would be most necessary. And that concludes our discussion today on wireless network cabling. Be sure to move on to your chapter review. It's a nice small one, only 4 questions, asking you what is the most common wireless data signal, what is an access point, what is the wireless technology designed for low cost, low power, short range links. Okay, I'll give you a hint. It's blue. Has to do with teeth. And what are the 2 primary concerns for performing a site survey? Give you another hint. Got it. All right. So join us next for testing our voice data and video wiring.